June 6, 1944. Normandy Beach. The world watched as Allied forces stormed the beaches of Nazi-occupied France in the largest amphibious invasion in human history. The images were iconic: soldiers wading through surf under withering fire, landing craft disgorging men and machines onto blood-soaked sand, the massive industrial might of democracy crashing against Hitler's Atlantic Wall. The beaches fell. Within hours, then days, Allied forces pushed inland. The breakthrough everyone had prayed for was happening. Victory seemed inevitable, just a matter of time and determination. Paris would be liberated. Germany would be defeated. The war in Europe would end, except it didn't happen that way. Not even close. By June the 12th, just 6 days after the initial landings, the entire Allied advance had ground to a complete and total halt. American, British, and Canadian forces were stuck in a narrow coastal strip, advancing only a few hundred yards per day through grinding, bloody combat. The rapid push to Paris that planners had envisioned became a nightmare of static warfare that resembled World War I more than the mobile warfare everyone expected. The culprit wasn't German panzer divisions, though they fought fiercely. It wasn't artillery or machine guns, though both took terrible tolls. The obstacle that stopped the mightiest invasion force ever assembled was something far more mundane, something that had been there for centuries, ignored by invasion planners because it seemed too simple to matter. Hedgerows. These weren't the decorative hedges you might have in your backyard. Neat rows of trimmed bushes marking property lines. Norman hedgerows were ancient barriers, living fortresses that farmers had built over centuries to mark field boundaries and contain livestock. Some dated back to Roman times. They were walls of compacted earth, stone, and tangled roots, often 15 feet tall and just as thick at the base. The root systems went down 10 feet or more into the Normandy soil, creating a network of vegetative concrete that was nearly impenetrable, and they were everywhere. Normandy's agricultural landscape was a patchwork of small fields, each one surrounded by hedgerows. From the air, it looked like a massive maze. On the ground, it was a series of natural fortresses, one after another, stretching inland as far as anyone could see. The Germans, who had occupied France for 4 years, understood these hedgerows intimately. They knew every field, every gap, every natural killing zone, and they had turned the entire Norman countryside into the most effective defensive terrain imaginable. For American tank crews, these hedgerows became death traps. Every time a Sherman tank tried to advance into a new field, it had to cross a hedgerow. The only way to do that was to climb over it, drive the tank up the earthen wall until it crested the top and could descend into the field beyond. But that maneuver exposed the Sherman's belly armor, and the Sherman's belly armor was the thinnest part of the entire tank, just over an inch thick in most places, sometimes less. It was designed to be protected by the ground itself. Sherman tanks were never supposed to expose their undersides to enemy fire. German soldiers knew this. They positioned themselves on the far side of hedgerows with panzerfausts, handheld anti-tank weapons that could punch through weak armor like paper. They didn't need to fight the Shermans head-on, where American frontal armor was thick enough to withstand most German weapons. They just had to wait. Wait for the inevitable moment when a Sherman tried to climb a hedgerow. When its underside tilted up toward the sky, when all that vulnerable belly armor was exposed for just a few seconds, that was all they needed. One shot, one kill. The nightmare played out dozens of times every day across Normandy. Tank commanders would survey a hedgerow, knowing what they had to do, but knowing what would probably happen. The crew would brace themselves. The driver would gun the engine and charge the earthen wall. The tank would climb, tilting back at a steep angle, tracks churning against ancient roots and compacted soil. For a moment, it seemed like it might work. The tank was cresting, almost over. Then came the flash of a Panzerfaust launch from the other side. The hollow charge warhead would strike the exposed underside with devastating effect, penetrating the thin armor and sending a jet of superheated metal into the crew compartment. The tank would erupt in flames. Ammunition would cook off. If the crew was very lucky and very fast, they might escape before the fire consumed them. Most weren't lucky. Most didn't escape. Sergeant Curtis Culin of the 102nd Cavalry Reconnaissance Squadron watched this nightmare unfold daily. He saw tanks approach hedgerows with the grim determination of men going to their execution. He saw the desperate attempts to climb the ancient barriers. He heard the distinctive crack of Panzerfaust launches. He saw Shermans erupt in flames, saw crew members burning, saw the lucky ones who made it out traumatized and injured. He saw it so many times that he stopped being able to sleep. The medics were overwhelmed. The Graves registration units worked overtime. The replacement system struggled to provide new crews as fast as the hedgerows were killing existing ones. And the advance, the critical advance that was supposed to break German resistance and liberate France, crawled forward at a pace measured in yards per day, not miles. The tactical situation was desperate. Allied planners had expected to be 30 miles inland by mid-June, pushing toward Paris and the Seine River, disrupting German communications and supply lines, forcing Hitler to commit reserves to defend his western territories. Instead, they were stuck in a strip of Norman countryside barely 10 miles deep, fighting for every hedgerow, every field, every few hundred yards of ground. The Germans didn't need massive reinforcements. They didn't need to launch counterattacks or try to push the Allies back into the sea. They just needed to sit tight behind these ancient hedgerows and wait. The terrain was doing their fighting for them, bleeding the Allies white in the most efficient way possible. High-level commanders held emergency conferences. Engineers were brought in to study the problem. Various solutions were proposed and tested. Could artillery destroy the hedgerows? It barely scratched them. Centuries of growth had created root systems that could withstand anything short of massive explosive charges. Could bulldozers clear paths? German observers would spot the bulldozers and call in mortar fire, killing the operators before they could finish their work. Could infantry find gaps in the hedgerow network? Sometimes, but those gaps were few, predictable, and heavily defended. Nothing worked consistently. The hedgerow problem seemed unsolvable, at least not without accepting casualty rates that would cripple the entire invasion. Every passing day increased German strength as reinforcements arrived. Every stalled attack gave Hitler more time to fortify France's interior. The success of D-Day was beginning to look hollow if the Allies couldn't break out of Normandy. Meanwhile, Sergeant Curtis Culin watched and thought, and unlike the high-level commanders and professional engineers, Culin was looking at the problem from a different angle. He wasn't thinking about complex solutions or sophisticated engineering. He was thinking like a mechanic, practically, directly, without concern for elegant theory. The problem, as Culin saw it, was simple. Tanks were trying to go over the hedgerows when they should be going through them. Curtis Culin was not the man anyone expected to change the course of the Normandy campaign. He had no engineering degree, no formal military training in armor tactics or battlefield innovation, no connections to high command or influence with the generals making strategic decisions. He was just a sergeant, an enlisted man, a mechanic, the kind of person who fixed things when they broke and was otherwise ignored by the officers planning the war. He had been born in 1915 in Cranford, New Jersey, a small town where everyone knew everyone and most people worked with their hands. His father had been a machinist at a local factory. His mother had taken in sewing to help make ends meet during the Depression. Curtis grew up understanding that you worked hard, you didn't complain, and when something broke, you fixed it yourself because hiring someone else wasn't an option. He'd shown an aptitude for mechanics from an early age. While other boys played baseball or chased girls, Curtis was taking apart his neighbor's lawnmower to see how it worked. or helping his uncle restore an old car engine in a cramped garage. He had an intuitive understanding of how mechanical systems functioned, how force translated into motion, how parts interacted, how to diagnose problems by sound or feel or simple observation. After high school, he'd gotten a job at a local garage, fixing cars and trucks for farmers and working-class families who couldn't afford dealership repairs. He was good at it. More than good, he had a reputation for solving problems that stumped other mechanics. Engines that wouldn't start, transmissions that made mysterious noises, electrical systems that failed in ways that made no sense. Culin would study the problem, think it through, and find the solution. His method was straightforward. Strip away everything that didn't matter. Focus on the actual problem. Understand what was supposed to happen and what was actually happening. Then find the simplest fix that would bridge that gap. He didn't care if the solution was elegant or followed proper procedure. He cared if it worked. When Pearl Harbor was attacked in December 1941, Culin enlisted like millions of other young Americans. He was assigned to a cavalry reconnaissance unit, cavalry in name only, since they rode in armored vehicles rather than on horses. His mechanical skills made him valuable. While other soldiers were being trained in combat tactics, Culin was maintaining the unit's vehicles, keeping jeeps running, fixing radios, welding broken parts back together. He wasn't a combat soldier in the traditional sense. His weapon was a wrench, not a rifle. His battles were fought against mechanical failures, not German soldiers. But he saw combat nonetheless, saw it from the perspective of the mechanics who had to recover damaged vehicles, who had to patch bullet holes and repair shrapnel damage, who had to pull burned bodies out of destroyed tanks so the vehicles could be salvaged. By June 1944, Culin had been in Normandy for a week. His unit had landed on D-Day +1, coming ashore after the initial beachhead had been secured. Since then, he'd been working around the clock maintaining vehicles, repairing battle damage, keeping the unit mobile in the face of constant mechanical stress. And every day, he watched tanks burn trying to cross hedgerows. Every day, he helped recover the wrecks, cutting through twisted metal to reach trapped crew members, some alive, most not. Every day, the hedgerow problem gnawed at him like a mechanical failure he couldn't diagnose. His crewmates had started to notice Culin's obsession with the hedgerows. They'd see him studying them during breaks, walking around them, examining the root structures, testing how they responded to pressure. They'd catch him sketching in a small notebook he always carried. Diagrams and calculations and design ideas. Culin's at it again, they'd joke. Going to solve the whole war with his little drawings. They meant it affectionately, but there was an edge of skepticism, too. A lot of smart people had looked at the hedgerow problem. Professional engineers with university degrees, tank designers who understood armor and ballistics, tactical planners with years of military experience. None of them had solved it. What made one sergeant from New Jersey think he could do better? Culin ignored the skepticism because he'd heard it before. People always underestimated mechanics. They assumed that because you worked with your hands and got grease under your fingernails, you didn't work with your mind. They didn't understand that every good mechanic was fundamentally a problem solver. Every repair was a puzzle. Every diagnosis required analytical thinking. You had to understand systems, not just how they were supposed to work, but how they failed, how stresses accumulated, how to compensate for weaknesses. The hedgerows were just another kind of mechanical problem. They were obstacles preventing movement. Movement required force applied in the right way at the right point. If you understood the engineering, the actual physical engineering, not abstract theory, you could find a solution. And Culin thought he had one. The idea came to him on June 11th, watching yet another Sherman burn after attempting to climb a particularly massive hedgerow. He was standing with his unit, waiting to see if any crew members would emerge from the flaming wreck. None did. The tank burned for hours, ammunition cooking off periodically, sending up columns of black smoke visible for miles. Culin was sketching in his notebook again, trying to work through the problem methodically. The issue was exposure. Climbing over the hedgerow exposed the tank's vulnerable underside to enemy fire. So the solution was simple. Don't climb over it. Go through it instead. But how do you go through 10 feet of compacted earth and ancient roots? You can't just drive through. The hedgerow was too solid, too massive. The tank would get stuck, or worse, would tilt forward and get hung up on the root mass. Creating an even better target than climbing over would have been. Then it hit him. Leverage. You needed leverage against the base of the hedgerow. Something that could dig into the earth and roots at ground level, creating mechanical advantage that would let the tank's weight and power rip through the barrier instead of climbing over it. Steel prongs. Sharp, angled steel prongs welded to the front of the tank, low enough to engage the hedgerow at its base. The tank would charge forward, and the prongs would bite into the ancient earth like teeth, then use the tank's momentum and weight to tear through what couldn't be climbed. Culin sketched rapidly, working out angles and dimensions. The prongs had to be positioned correctly. Too high, and they'd cause the same climbing problem. Too low, and they'd just plow dirt without cutting roots. The angle of attack mattered. The strength of the welds mattered. The length and thickness of the prongs mattered. But it was doable. He was certain it was doable. And the materials were available. The beaches were littered with German beach obstacles called Czech hedgehogs, massive steel structures that had been intended to stop landing craft but had been largely bypassed in the invasion. Those hedgehogs were made of heavy steel beams welded together. Perfect for what Culin had in mind. The real question was whether anyone would let him try. Sergeant Culin approached his commanding officer, Captain Samuel Morrison, with a proposal that sounded completely insane. He wanted to take a damaged Sherman tank, one that had been hit but was still mobile, and weld steel prongs to its front. These prongs, made from German beach obstacles, would act like giant knives. The tank would ram into hedgerows at full speed, and the prongs would dig in and rip through the earth and roots, creating a breach without ever exposing the tank's vulnerable underside. Captain Morrison stared at Culin like he'd lost his mind. "Let me understand this, Sergeant," Morrison said slowly. "You want to take a tank that's already been shot at, weld scrap metal to the front of it, and then deliberately drive it full speed into a solid earthen wall. That's your plan?" "Yes, sir," Culin replied calmly. "The current plan is to drive tanks over hedgerows where they get shot in the belly. My plan keeps the armor facing the enemy at all times. The Germans can't penetrate frontal armor. They need that belly shot. If we never give them that shot, they can't kill the tank." Morrison was silent for a long moment. The logic was actually sound, as crazy as it sounded. The whole hedgerow problem came down to that moment of exposure when tanks climbed over the barriers. If Culin's contraption could avoid that exposure, how long would it take to build this thing? Morrison asked. "Give me 2 days, some welding equipment, and permission to scavenge metal from the beach obstacles," Culin said. "I'll have a prototype ready." Morrison made a decision that would change the course of the Normandy campaign, though he didn't know it at the time. "You have 48 hours. If this doesn't work, we're both going to be explaining ourselves to some very angry generals. But if it does work—" He paused, considering the implications. "If it works, Sergeant, you might have just saved this invasion." Culin saluted and got to work immediately. He didn't have time to waste celebrating or second-guessing. 48 hours to build something that had never been built before, test it, and prove it could work in combat. Most engineering projects took months. He had 2 days. He requisitioned an acetylene torch, welding equipment, heavy hammers, and measuring tools. He assembled a small work crew, men who knew how to weld and weren't afraid of hard work. Then he led them to Omaha Beach, where the initial D-Day landings had taken place just days earlier. The beach was a surreal landscape. Landing craft still littered the sand. Abandoned equipment lay scattered everywhere, and among it all, spread across the beach like industrial sculpture, were German defensive obstacles. Massive steel structures, concrete barriers, wooden stakes with mines attached. The Germans had turned the beach into a killing ground, and the physical remnants of that effort now covered the sand. The Czech hedgehogs were perfect for Culin's purpose. These were anti-tank obstacles made of 3 heavy steel beams welded together in the shape of a giant jack, like a children's toy, but made of hardened steel and weighing hundreds of pounds each. The Germans had planted thousands of them on the beaches, thinking they'd stop tanks and landing craft. Instead, they'd been largely bypassed or destroyed in the initial assault. Now they were scrap metal, waiting to be repurposed. Culin and his crew began cutting the hedgehogs apart with torches. The work was hot, dangerous, and exhausting. The acetylene flames roared as they sliced through hardened steel. Sparks flew in great cascading showers. The smell of hot metal and burning beach debris filled the air. They worked through the night, cutting and trimming steel beams to the right length, about 4 feet each. They sharpened the tips to help them bite into earth and roots. They reinforced weak points in the steel where German explosives had damaged the original structures. By dawn on the first day, they had 4 prongs ready, each one thick as a man's leg and as hard as railroad track. The next phase was more delicate. They had to weld these massive prongs to the front of a Sherman tank without compromising the tank's structural integrity or interfering with its ability to move and fight. Culin had worked out the calculations carefully in his notebook. The prongs had to be positioned at exactly the right angles, low enough to engage hedgerow bases, angled slightly downward to promote digging rather than climbing, spaced wide enough to rip through a broad section of earthwork. He marked the positions on the Sherman's hull with chalk, double-checking his measurements. One mistake here, and the entire contraption would be useless, or, worse, would actually make the hedgerow problem worse by getting tanks stuck in new and creative ways. "You really think this will work?" asked Private Eddie Kowalski, one of the welders helping with the project. He was a good kid, barely 20 years old, skilled with a torch, but skeptical of the whole enterprise. "I know it'll work," Culin replied with more confidence than he felt. He adjusted his welding mask and struck an arc. The physics are solid. Steel teeth driven by 30 tons of tank hitting earth and roots. Something's got to give, and it won't be the steel. They welded through the entire second day, taking breaks only when absolutely necessary. The work was precise and demanding. Each weld had to be perfect, strong enough to withstand tremendous impact forces, positioned exactly right to transfer those forces into the tank's structure without causing damage. A weak weld would mean the prongs snapping off on impact, turning a potentially revolutionary device into useless scrap metal. Culin checked every weld personally, running his hands over the metal to feel for weaknesses, examining the work from every angle. He'd been welding for years, had learned the craft from his father, and he knew what good work looked like. These welds were good. They'd hold. By dawn on the second day, the modification was complete. The Sherman tank, already scarred from previous combat, bearing the marks of German fire that had damaged but not destroyed it, now had 4 massive steel prongs extending from its front like the tusks of some mechanical beast. The transformation was striking. Where before the tank had looked like a standard Sherman, now it looked like something new, something purposeful and aggressive. Soldiers began gathering to look at the strange creation as word spread through the camp. Some were impressed by the sheer audacity of it. Others were openly skeptical, making jokes about Culin's sanity and taking bets on whether the sergeant would be court-martialed or commended. "Looks like a pig trying to mate with a porcupine," one soldier joked, triggering laughter from the crowd. Culin patted one of the steel prongs affectionately, feeling the solid weight of it, checking the weld one last time. Maybe so, he said quietly. But this pig's about to root through every hedgerow between here and Berlin. Captain Morrison walked around the modified tank slowly, examining the welds, testing the strength of the prongs with his hands, trying to imagine what would happen when this thing hit a hedgerow at full speed. Finally, he nodded. "All right, Sergeant. You've built your mad contraption. Now you need to prove it works. Tomorrow morning, we're going to find a nice thick hedgerow and see if this thing is genius or suicide." That night, Culin couldn't sleep. His mind kept running through the calculations, the physics, the potential failure points. The math worked. The engineering was sound. But there was always a difference between theory and reality, between what should happen and what actually happened when steel met Earth at high speed. What if the prongs snapped on impact? What if they dug in too deep and the tank became stuck, creating an even better target than climbing the hedgerow would have? What if the whole crazy idea just made things worse? He thought about all the tank crews who had died trying to cross hedgerows in the past week. Men who had survived the D-Day landings only to be killed by ancient earthworks and German anti-tank weapons. If his invention worked, it could save future crews. But if it failed, he'd be responsible for wasting time and resources that could have been spent on other solutions. Around midnight, Private Kowalski found him sitting outside the repair tent, staring at his notebook by lantern light. "Can't sleep either?" Kowalski asked, sitting down next to Culin. "Too much thinking," Culin admitted. "Tomorrow we find out if I'm a genius or an idiot." "My money's on genius," Kowalski said. "I've been a welder for 3 years, Sarge. I've seen a lot of field modifications, a lot of crazy ideas. Most of them are crap, people who don't understand engineering trying to reinvent the wheel. But your design is solid. The welds are good. The physics make sense. If there's a problem tomorrow, it won't be because you built something wrong. It'll be because the problem is impossible to solve. And I don't think it is." Culin wanted to believe that. He needed to believe that. But he wouldn't truly know until tomorrow, when 30 tons of steel met centuries-old earthwork and only one of them could win. The morning sun had barely cleared the horizon when Culin's modified Sherman rolled toward the designated test site. A particularly thick hedgerow had been selected for the demonstration. A beast of a barrier, 12 feet high and ancient. The kind that had been stopping American armor cold for the past week. Several officers had gathered to watch, including Captain Morrison and Major Jack Williams from Division Headquarters. The presence of a major meant that word of Culin's experiment had reached higher command. Either this test would vindicate his idea and launch a revolutionary new capability, or it would end his career in spectacular fashion. The Sherman's crew had volunteered for the test run. Driver Corporal Jake Mitchell, Gunner Sergeant Tom Harrison, and Loader Private First Class Danny Chen. They were either exceptionally brave or completely insane, possibly both. As they climbed into the tank and prepared to button up, their expressions showed a mix of determination and barely controlled fear. Culin stood with the observers, his heart pounding so hard he could feel it in his throat. Everything he'd calculated, everything he'd built, every assumption he'd made about physics and engineering came down to the next 60 seconds. If it worked, they'd revolutionize the Normandy campaign. If it failed catastrophically, good men might die, and he'd be the one responsible. "Ready?" Captain Morrison asked, looking at Culin. "As I'll ever be, sir." Morrison raised his arm, then dropped it sharply, the signal to proceed. The Sherman's engine roared louder, a deep mechanical bellow that echoed across the field. Black smoke belched from the exhaust. Then, with gathering speed and terrible purpose, the 30-ton tank charged directly at the hedgerow that had stood unmoved for centuries. The impact was thunderous. The entire tank shuddered with the force of the collision. Earth exploded outward in a massive spray. Roots snapped with sounds like rifle shots, sharp cracks that punctuated the roar of the engine. For one terrible moment, the tank seemed to stall, embedded in the hedgerow's mass, neither advancing nor retreating. Every soldier watching held their breath. Then, slowly at first, the Sherman began to move forward. The steel prongs were working, actually working. They had dug deep into the ancient earthwork, creating leverage, using the tank's weight and momentum to rip through roots and stone that had resisted every previous attempt. The tank tilted forward slightly, nose down but critically. It never exposed its belly armor. The vulnerable underside remained protected, while the thick frontal armor faced any potential threat. More roots snapped in rapid succession. Dirt cascaded off the tank's hull like water. The engine screamed with effort, pushed to its limits. And then, suddenly, the Sherman burst through the far side of the hedgerow, emerging into the field beyond in a spray of earth and shattered roots. The tank had created a perfect breach, wide, enough for other vehicles to follow, low enough that the Sherman's vulnerable underside had never once been exposed to where German anti-tank weapons would have been positioned. The gathered soldiers erupted in cheers. Some threw their helmets in the air. Others slapped each other on the back, unable to believe what they'd just witnessed. Culin felt his knees go weak with relief, his hands shaking as the adrenaline finally caught up with him. It had worked. His crazy idea had actually worked. The Sherman's crew popped their hatches and emerged, grinning like men who'd just won the lottery. Corporal Mitchell climbed out first, his face flushed with excitement. That was the smoothest hedgerow crossing I've ever experienced, he shouted to the crowd. We barely felt the impact inside, and we never once, not for a single second, exposed our belly to enemy fire. Whatever Sergeant Culin built, it's a miracle. Major Williams approached Culin, his expression unreadable. For a moment, Culin's heart sank, worried that somehow he'd still done something wrong, violated some regulation, overstepped his authority. Then the Major smiled. Sergeant, how many of these modifications can you produce, and how quickly? Sir, if I get enough welders and access to more hedgehog obstacles, my crew could modify 10 tanks a day. Maybe more if we really push it. Not good enough, Williams said, and Culin's brief hope deflated instantly. Then Williams's smile widened. I'm going to get you 50 welders and all the steel you need. I want 100 tanks modified by the end of the week, and I'm sending a report to General Bradley immediately. This invention is going to change everything. Captain Morrison clapped Culin on the back hard enough to make him stagger forward a step. Congratulations, Sergeant. You're no longer the mad mechanic. You're the genius mechanic who just saved the Normandy campaign. But Culin wasn't celebrating yet. Sir, with respect, one successful test doesn't mean it'll work in actual combat. We need to try this against a real German position with actual enemy fire. That's the only way to know if it's truly effective. Morrison's expression sobered. I thought you might say that. There's a German strongpoint about 2 miles from here. They've been holding up our advance for 3 days. Every approach is blocked by hedgerows, and every attempt to cross has been suicide. Battalion command wants it taken. But nobody's figured out how. He paused, looking at the modified Sherman, then back at Culin. If your contraption works there, under fire, it'll prove the concept beyond any doubt. But, Sergeant, if it doesn't work, good men will die trying. When do we go, sir? Tomorrow at dawn. I'm assigning you to the tank as technical advisor. You'll ride with Mitchell's crew. If there are problems with the equipment, you need to be there to see them, understand why they happened, and figure out how to fix them. Culin swallowed hard. He'd been hoping to stay safely in the rear, just building more modifications. But Morrison was right. He needed to see his invention in actual combat. Only then would he know if the design needed improvements. Only then could he honestly say it was ready for mass production. Understood, sir. I'll be ready. That night, Culin checked and rechecked every weld on the modified Sherman, now nicknamed Rhinoceros by the crew. He tightened every bolt. He examined the prongs for any stress fractures from the test. He went over the tank inch by inch, looking for any weakness, any potential failure point. Everything looked solid, but combat was different from controlled tests. In battle, nothing went according to plan. Murphy's Law applied with brutal efficiency on the battlefield. Private Chen found him working late by lantern light, still checking welds at well past midnight. "Sergeant, you should get some rest. Big day tomorrow." "Can't sleep, Chen. Too much thinking." "You scared?" Culin considered lying, maintaining the sergeant's facade of unshakable confidence. Then he decided honesty was better. "Terrified. This thing works in theory. It worked in one test. But tomorrow, people's lives depend on whether I got the math right. If I made a mistake somewhere, if there's a design flaw I didn't see..." "Then we trust you saw everything," Chen said simply. "You built this thing. You know it better than anyone. And tomorrow, we're going to plow through those hedgerows and show the Germans they can't hide anymore. I believe that. Mitchell believes it. Harrison believes it. Maybe you should believe it too." Culin wished he had Chen's confidence. All he could do was prepare as thoroughly as possible and hope that his mad idea was actually genius after all. Tomorrow would be the real test. Not against an empty hedgerow on a test range, but against enemy soldiers with weapons designed to kill tanks. Tomorrow would prove whether one sergeant's simple idea could actually change the course of a war. Of Part 1, The Mad Mechanic, who turned a broken tank into a battlefield. Legend Part 2, The battle test dawn broke over Normandy with a cold drizzle that made everything gray and miserable. The kind of morning where moisture hung in the air without quite becoming rain, where visibility was poor and footing was treacherous. Not ideal weather for a combat test, but war didn't wait for perfect conditions. Sergeant Curtis Culin climbed into the Sherman tank they'd nicknamed Rhinoceros, taking position in the commander's cupola where he could observe everything and provide technical advice to the crew. His stomach churned with nervous energy. He'd barely eaten breakfast, and the coffee he'd forced down now sat uneasily in his gut. This was different from yesterday's test. Yesterday had been controlled, safe, with observers and no actual enemy. Today, they would advance on a German strongpoint that had been killing American soldiers for 3 days. Today, Germans with anti-tank weapons would be watching, waiting, trying to kill them. The plan was straightforward, at least on paper. The Rhinoceros would lead a small column toward the German position. They'd use the hedgerow cutter to breach barriers that had previously stopped all advances. Infantry would follow close behind, using the breaches to advance without being caught in the killing zones the Germans had established. "Mount up," came the order from Captain Morrison. Engines rumbled to life across the staging area. The Rhinoceros shuddered and began rolling forward, its steel prongs gleaming wetly in the dawn drizzle. Culin's hands gripped the edge of the cupola, knuckles white with tension. They approached the first hedgerow. Beyond it, according to intelligence reports, was a German machine gun nest that had been mowing down American infantry for days. The position was well protected, dug into the far side of the hedgerow, where it had perfect fields of fire, but was nearly impossible to assault directly. The usual tactic would be to try climbing over the hedgerow, exposing the tank's belly to a Panzerfaust shot. German anti-tank teams would be waiting for exactly that moment, the instant when vulnerable armor appeared, giving them their one clear killing shot. "Steady," Culin said over the intercom, trying to keep his voice calm despite the fear coiling in his chest. Hit it at a slight angle, about 20 degrees. That'll help the prongs bite in properly." "Roger that," Corporal Mitchell replied, adjusting their approach line slightly. The impact came with a bone-jarring crash that made Culin's teeth rattle. Earth and roots exploded around them in a massive spray. Inside the tank, the crew was thrown forward against their restraints. But nothing broke. The prongs actually held under combat conditions. The tank pushed forward, its engine screaming with effort, tracks churning through centuries-old earth. And then they were through. They burst into the field beyond to find a shocked German machine gun crew scrambling for their weapon. The Germans had been positioned to fire at infantry, approaching through the narrow gaps in the hedgerows, or at tanks that exposed their undersides climbing over. They hadn't expected a Sherman to simply appear through the hedgerow itself, emerging at full speed with its main gun already trained on their position. Sergeant Harrison, the gunner, didn't hesitate. One high-explosive round eliminated the German position before they could bring their weapons to bear. The machine gun and its crew simply ceased to exist in a blast of smoke and shrapnel. "It works!" Private Chen shouted over the intercom, his voice pitched high with adrenaline and relief. "It actually works in combat!" But there was no time to celebrate. More hedgerows lay ahead, and behind each one could be more enemy troops, more weapons, more threats. The rhinoceros continued its advance, breaching hedgerow after hedgerow with mechanical efficiency. Each time, the prongs performed exactly as Culin had designed them to. Each time, the tank emerged before Germans could effectively respond. The infantry following behind the rhinoceros were ecstatic. For the first time since D-Day, they could advance without being pinned down by hedgerow defenses. They poured through the breaches the tank created, clearing German positions that had seemed impregnable just hours before. Positions that should have cost dozens of lives to take were falling with minimal casualties. Culin allowed himself a moment of cautious optimism. It was working, not just in a controlled test, but in actual combat against actual enemies trying to kill them. His design was sound. Then came the real challenge. "Contact front," Harrison called out sharply. German Panther tank, partial cover behind a massive hedgerow. Culin's blood ran cold. A Panther was a far more dangerous opponent than infantry or machine guns. The Panther's 75mm gun could destroy a Sherman at long range, punching through American armor like it was paper. If the rhinoceros got stuck while breaching the hedgerow, even for a few seconds, they'd be a sitting duck. Culin's mind raced through options. They could retreat, call for artillery support, play it safe. That's what doctrine said. Don't engage superior German armor without numerical advantage or tactical support. But retreat meant the mission failed. It meant the hedgerow cutter's effectiveness under pressure would remain unproven. It meant giving up the element of surprise. Once the Germans understood what the Americans had developed, they'd adapt their defenses. "Breach the hedgerow," Culin ordered, his voice surprisingly steady despite his racing heart. "Don't stop for anything. We go through fast and emerge with our gun already aimed where that Panther is. Speed is our only advantage." "Are you insane?" Harrison asked, not insubordinately but with genuine concern. "If we get stuck, then we die," Culin interrupted. "But if we don't try, more men die tomorrow and the day after when the Germans figure out what we're doing and adapt. We have surprise right now. Use it." Mitchell didn't hesitate. The Sherman surged forward at maximum speed. The impact was massive. This hedgerow was thicker than any they'd hit yet, ancient and incredibly dense. For a terrifying moment, the tank seemed to slow, the prongs struggling against the sheer mass of compacted earth and roots. "More power!" Culin shouted into the intercom. "Give it everything!" The engine howled like a wounded animal. Smoke poured from the exhausts in thick black clouds. The tracks threw up huge sprays of earth and torn roots. And inch by agonizing inch, the rhinoceros forced its way through. They burst through the hedgerow at an angle, Not perfect positioning, but good enough. Harrison had kept his gun trained on where the panthers should be based on their last sighting, compensating for the rhinoceros's movement through pure skill and instinct. As they emerged in a spray of earth and shattered roots, there it was, the German panther, its turret still turning to track their unexpected appearance through what should have been an impenetrable barrier. Harrison fired first. The armor-piercing round struck the panther's side armor, which was significantly thinner than its legendary frontal armor. The penetration was good, not catastrophic, but enough. The German tank shuddered, smoke pouring from hatches as internal components were damaged. The Panther's crew bailed out, abandoning their wounded vehicle. The rhinoceros's machine guns persuaded the German tank crew to surrender rather than fight. Within moments, American infantry caught up and secured the prisoners. An infantry lieutenant approached the rhinoceros, his face split by an enormous grin. "Sergeant Culin, I don't know what kind of witchcraft you worked on this tank, but you just did in 2 hours what we've been trying to do for 3 days. That German strong point is finished. You broke their defensive line." Culin climbed out of the tank, his legs shaky with adrenaline, come down, and relief. They'd done it. The Hedgerow cutter worked, not just in tests, not just against infantry positions, but in actual combat against combined German defenses, including armor. His mad idea had proven itself under the most demanding conditions possible. Captain Morrison arrived shortly after, his radio crackling with excited chatter from other units who'd witnessed the breakthrough. "Sergeant Culin, I just got word from division headquarters. General Bradley himself wants to see you. Major Williams's report apparently made quite an impression. They're calling your invention the Culin Hedgerow cutter, and they want 5,000 of them manufactured immediately." 5,000. Culin could barely process the number. His little modification, built in 48 hours from scrap metal, was going to be mass-produced and deployed across the entire Allied armored force. "Sir, I'm just a mechanic. I'm not sure I'm qualified to—" "You're the man who solved the hedgerow problem," Morrison interrupted firmly. "Own it, Sergeant. You just changed the course of this war. Now we need you to help us scale up production, so every tank in Normandy gets one of these cutters." Within days of the rhinoceros's combat success, the Allied war machine kicked into high gear. Every tank depot in Normandy received urgent orders to begin installing Culin Hedgerow cutters. The Army brought in welding teams from engineering battalions. They scavenged every Czech hedgehog they could find from the invasion beaches. They set up assembly lines in muddy fields, working around the clock under tents and tarps. Culin found himself pulled from his unit and assigned to training duty. He went from depot to depot, showing welding crews the exact angles for the prongs, the proper welding techniques, the reinforcement methods that would prevent the cutters from snapping off under stress. "The key," he explained to each new group, of welders gesturing at a demonstration tank, "is that the prongs have to dig in low. If they're positioned too high, the tank tilts up and exposes its belly, the exact problem we're trying to solve. Too low, and they just plow dirt without cutting roots. You want them positioned exactly here." He'd mark the spot with chalk, a 15-degree downward angle from horizontal. That gives you optimal cutting action against the root mass. Some welders were skeptical at first. The design looked crude, primitive even, just steel prongs stuck onto a tank. Where was the sophisticated engineering? Where were the complex systems? But when Culin showed them combat footage of rhinoceros-style tanks plowing through hedgerows that had stopped entire companies, skepticism turned to enthusiasm. They worked faster, taking genuine pride in the modifications they were installing. General Omar Bradley himself visited one of the tank modification sites personally. His jeep rolled up unannounced, while Culin was elbow-deep in a welding project, training a new crew on proper technique. Bradley stepped out, his uniform immaculate, despite the mud and chaos of the depot. Culin snapped to attention when someone shouted that a general was present. He turned to see the stars on Bradley's collar and felt his stomach drop. "Sergeant Culin, I presume?" Bradley said, his tone friendly rather than stern. "Yes, sir." "At ease, Sergeant." Bradley smiled, a genuine expression that put Culin slightly more at ease. "I came to see the man who unstuck my entire army. Your invention is brilliant in its simplicity. We've been throwing sophisticated engineering, solutions at the hedgerow problem for weeks. Artillery barrages, explosive charges, modified bulldozers. Nothing worked consistently. Then you come along with scrap metal and a welding torch and solve it in 2 days." "Sir, I just did what needed doing," Culin replied, uncomfortable with the praise. "That's what good soldiers do," Bradley finished the thought. "They identify problems and solve them without waiting for someone else to figure it out. I'm recommending you for the Legion of Merit, and I'm also authorizing a field promotion to technical sergeant. This army needs more men who can think outside the box." After Bradley left, Culin's crewmates mobbed him with congratulations. But Culin felt conflicted. He was being lauded as a genius, receiving medals and promotions, but men were still dying all over Normandy. His invention was helping. God, it was helping tremendously. But it wasn't magic. The war was far from over. Germans were still fighting. Americans were still bleeding. Private Kowalski, who'd helped with the original prototype, pulled him aside. "You okay, Sarge? You don't seem too excited about all this recognition." "I am," Culin said, trying to articulate the complicated feelings churning in his chest. I keep thinking about all the tank crews we lost before this invention. What if I'd thought of it sooner? What if I'd pushed harder to get it tested earlier? Maybe some of those men would still be alive." Kowalski gripped Culin's shoulder firmly. "You can't think like that. You can't save the guys who died before, but you're saving the guys who are still alive. Every day, more tanks with your cutters are rolling through hedgerows. Every day, fewer crews are burning. That's what matters, Sarge. Not what you couldn't do before, but what you're doing now." Culin knew Kowalski was right intellectually, but guilt didn't respond to logic. In quiet moments, he still thought about those early tank crews who died attempting to climb hedgerows. If only he'd been faster. If only he'd been more insistent. If only. But war didn't allow time for if only. It demanded forward movement, constant problem-solving, focused effort on saving whoever could still be saved. As the Culin hedgerow cutters saw widespread deployment, soldiers in the field began reporting back with suggestions and modifications. This was exactly what Culin had hoped for. The design iterating and improving based on actual combat experience. Some crews found that adding a 5th prong in the center improved cutting performance on particularly thick hedgerows. The additional prong created better balance and more cutting edges. Culin immediately approved the modification and updated his training materials. Other crews experimented with serrated edges on the prongs, which helped them grip and tear through stubborn root masses more effectively. A few creative tank commanders added reinforcement plates to protect the welds from enemy small arms fire. While German weapons couldn't threaten a tank's armor, concentrated rifle fire could potentially damage welds if given enough time. Culin embraced all these improvements with enthusiasm. "The best ideas come from the guys actually using the equipment," he explained to a visiting war correspondent. "I came up with the basic concept, but dozens of tank crews have contributed improvements. This isn't just my invention anymore. It belongs to every soldier who's made it better." One particularly clever modification came from a tank crew in the 3rd Armored Division. They'd noticed that the cutters sometimes got clogged with packed earthen roots reducing effectiveness on subsequent hedgerows. Inspired by agricultural equipment, they added a simple clearing mechanism that automatically shed debris from the prongs as the tank moved. It was a small change, but it meant tanks could breach multiple hedgerows in succession without stopping to manually clear the cutters. Culin immediately incorporated this improvement into his standard design. "See, that's genius right there," he'd tell new welding crews. "I never thought about debris clearance. Some tanker in the field saw the problem and fixed it." That's how good engineering happens, iteratively, with input from people actually using the product. The German response to the hedgerow cutters revealed just how effective they were. At first, captured German reports showed complete confusion. Enemy armor is now passing through hedgerows without exposing vulnerable areas. Mechanism unknown. Advise immediate investigation. Once they figured out what was happening, the Germans tried various countermeasures. They attempted to reinforce hedgerows with hidden mines, which worked occasionally but required massive resources. They positioned anti-tank guns at unusual angles where they might catch breaching tanks, which was tactically sound but required predicting exactly where Americans would breach. They even created fake hedgerows as traps, with pre-positioned weapons waiting for attacking tanks, which worked once or twice before American tactics adapted. But none of these countermeasures consistently worked. The fundamental problem remained. The Culin cutter allowed tanks to breach hedgerows while keeping thick frontal armor facing the enemy. As long as Allied tank crews used proper tactics, Germans couldn't effectively counter the new capability. By August 1944, as Allied forces finally broke out of Normandy and began racing across France toward Germany, the hedgerow cutter had become completely standard equipment. Culin found that story particularly amusing. "I built a tool to cut through bushes," he'd say with a wry smile. "Now they're using it to move disabled panzers. War makes you creative, I guess." But not all news was positive. Some tanks suffered equipment failures when cutters were used beyond their design specifications. Prongs snapped off when crews tried to push through reinforced concrete obstacles. Welds failed when tanks attempted to use cutters to lift objects. There were even cases of friendly fire incidents when other units didn't recognize modified tanks in poor visibility and mistook the prong silhouette for enemy equipment. Culin worked with Army engineers to develop better training materials. "The cutter is a tool, not magic," he emphasized in training sessions. "It has limitations. Use it wrong and you'll break it or get someone killed. Use it right, and it'll save your life and complete your mission." By early 1945, as Allied forces pushed into Germany itself, the hedgerow cutter had become so standard that new tankers barely remembered a time when Shermans didn't have them. The innovation had been normalized, integrated completely into doctrine and tactics. For Culin, this was both gratifying and melancholy. His invention had succeeded beyond his wildest dreams. But that very success meant people forgot it had ever been a problem. The hedgerow cutters were just there, part of the tank, unremarkable. "That's how you know something really worked," Captain Morrison told him during a rare reflective conversation. "When people can't imagine it ever being different." "You didn't just solve a problem, Curtis. You made the problem disappear so completely that nobody even remembers it existed." Germany surrendered on May 8, 1945. The war in Europe was over. Culin stood with his unit in a small German town, watching soldiers celebrate. There was joy, certainly, and relief, the incredible relief of having survived, but also exhaustion and emotions too complex to easily name. The hedgerow cutters had played their part in victory. By most estimates, they'd shortened the Normandy campaign by weeks, possibly months. That acceleration had cascading effects throughout the European theater. Faster advance across France, quicker liberation of Paris, earlier crossing of the Rhine, sooner arrival in Berlin. Every day saved meant lives saved, resources conserved, suffering reduced. Official citations credited the Culin Hedgerow cutter with materially contributing to the successful conclusion of the Normandy campaign and subsequent operations in the European theater. General Eisenhower himself called it one of the most significant tactical innovations of the war. Culin received the Legion of Merit, the Bronze Star, and a personal commendation from the Supreme Allied Commander. He was promoted to warrant officer. His name appeared in newspapers back home, where he became a symbol of American ingenuity. The average soldier who'd used common sense and scrap metal to solve a problem that had stumped experts. But as Culin stood in that Germantown watching celebrations, he felt oddly empty. The problem he'd solved no longer mattered. The war was over. The hedgerows of Normandy were a year in the past. His invention, revolutionary as it had been, was now just a footnote in the history of a conflict that had killed tens of millions. "You're thinking too much again," Kowalski said, appearing beside him with 2 bottles of liberated German beer. "Just reflecting," Culin replied, accepting a bottle gratefully. "A year ago I was welding prongs onto a tank, hoping my idea would work. Now the war's over and I'm trying to figure out what any of it meant." "It meant you saved lives," Kowalski said simply. "My life, probably. I was infantry before I got transferred to your welding crew. If I'd stayed infantry, if tanks hadn't been able to breach hedgerows, I'd probably be dead. So would hundreds of other guys. Your invention mattered, Sarge. Don't ever doubt that." They drank in silence, watching the sun set over ruined Germany. Curtis Culin returned home to New Jersey in late 1945, carrying medals and memories, but ready to leave the war behind. He went back to his old job at the garage, fixing cars and trucks. The skills that made him a wartime innovator served him well in peacetime. He was good with machines, good at solving problems, good at seeing solutions others missed. But he never talked much about the hedgerow cutter. When customers or friends asked about his war experiences, he'd deflect. "I was a mechanic. Fixed tanks. Nothing exciting." He didn't mention the medals. He didn't mention the innovations. He didn't mention that his invention had changed the course of the Normandy campaign. His wife Margaret once asked why he was so reluctant to discuss his wartime achievements. "You're a genuine hero," she said. "You should be proud." "I'm proud of what I did," Culin replied quietly. "But I'm not proud of what it was for. I made a tool that helped kill people. Yes, it saved American lives, which matters enormously, but it was still about killing. I'd rather focus on fixing things now, not on how I helped break things then." Over the decades, military historians gradually recognized the significance of the Culin hedgerow cutter. It appeared in books about the Normandy campaign, in documentaries about WWII innovations, in military training manuals as an example of field-expedient engineering. But Culin himself remained largely unknown outside military history circles. He preferred it that way. In 1984, 40 years after D-Day, a young historian named David Carter tracked down Culin, now 73 years old and long retired. Carter was writing a book about tactical innovations in World War II and wanted to interview the hedgerow cutter's inventor. "Mr. Culin, do you understand how significant your invention was?" Carter asked during their interview. "Military analysts estimate it shortened the Normandy campaign by weeks. It saved thousands of lives. It changed tank warfare doctrine permanently. And it all came from you, a sergeant with no engineering degree, in just 48 hours. Culin was silent for a long moment, staring at his weathered hands. Then he said something that Carter would include in his book as the perfect summary of American ingenuity. "I wasn't special. I was just a guy who knew how machines worked and saw a problem that needed solving. The special part was that the Army gave me a chance to try. How many other good ideas got dismissed because they came from the wrong person or the wrong rank? How many problems went unsolved because someone said, 'That's not how we do things'? I got lucky. My crazy idea got tested. But I guarantee you there were 100 other guys with equally good ideas that nobody listened to. But your idea worked, Carter pressed. That makes you special. My idea worked because people gave it a chance, Culin corrected gently. Captain Morrison could have said no. The test crew could have refused. Division Command could have rejected it after the first combat trial. But they didn't. They looked at the idea, not at who was suggesting it. That's the real lesson. Not that I was some genius, but that good ideas can come from anywhere if people are willing to listen. Curtis Culin died in 1993 at the age of 78. His obituary in the local newspaper mentioned that he'd been a mechanic, a veteran, and a quiet man who preferred fixing things to talking about them. It didn't mention the hedgerow cutter. Most of his neighbors never knew that the old man who'd fixed their cars had changed the course of World War II. But in military museums across America and Europe, examples of the Culin hedgerow cutter are preserved. Chunks of steel welded to the fronts of Sherman tanks. They look simple, almost crude. But those simple pieces of metal were revolutionary in their effectiveness. Plaques explain what they are and what they did. And occasionally, they mention the name Curtis Culin, the mad mechanic who refused to accept that problems were unsolvable. His legacy isn't just the invention itself. It's the lesson that genius can come from unexpected places. That practical experience sometimes trumps formal education. That the willingness to try impossible solutions can change history. That sometimes the best answer to a complex problem is breathtakingly simple if you're willing to see it. The hedgerow cutters saved thousands of lives. They shortened a campaign. They proved that innovation doesn't require advanced degrees or prestigious positions, just clarity of thought, willingness to try, and the courage to look foolish if you're wrong. Curtis Culin was a mechanic from New Jersey who saw a problem and built a solution with his own hands. He wasn't looking for glory or recognition. He just wanted to stop watching. Good men die for something as simple as an earthen wall covered in bushes. And in doing that, in focusing on the problem rather than seeking credit for the solution, he embodied the best of what ordinary people can achieve when given the chance to try. His story reminds us that the next world-changing innovation might not come from a laboratory or a boardroom. It might come from someone with grease under their fingernails, a notebook full of sketches, and a stubborn refusal to accept that the impossible can't be done. Sometimes, the mad mechanic turns out to be the genius the world needs.